Hi, my name is Zirfa Tahir, and this is my final project for Professor Wheeler's CIS 3367. And for this project, I'm working on the Solver tool. The Solver tool is located in the Add-in section of the Microsoft Excel. So in order to add in, we're going to go to File, select Options, we're going to go to Add-ins, and then we're going to click on the Solver add-in and then press OK. And then once we'll go on our Data tab, underneath it we can see that we have the Solver function add-in to our Excel sheet. Well, what is a Solver tool? Solver tool is an optimization tool that can come in handy when solving complex linear or nonlinear problems. With Solver, we can find an optimal maximum or minimum value for a formula in one cell. This is called the objective cell, which is a subject to constraint or limits on the values of other formula cells on a worksheet. Solvers work with a group of cells, also known as variable cells, that participate in figuring out the formulas in the objective and constraint cells. Solver adjusts the values in the decision variable cell to satisfy the limit on constrained cells and produce the desired result you want for the objective cell. Therefore, we can use Solver to solve various business analysis and problems. For this project, I mainly focused on two scenarios. In one scenario, we're going to be finding the maximum value that maximize the profit, whereas in the second scenario, we're going to find the value that minimize the payroll cost. For scenario 1, we're dealing with an electronic company that manufactures TV, stereos, and speakers, using a common parts inventory of the power supply, speakers, and cones. The problem that we're facing here is that the parts are in limited supply, and we must determine the most profitable mix of products to build. As our profit per unit will decreases volume because extra price incentives are needed to load the distribution channel. In this case, we're given 3 products: TV set, stereo, and speaker, which uses all the same parts of inventory. We have the inventory and we also have the not used inventory. As you can see, all the 3 products give us different profit margin. I have already performed the Solver tool on this data right here, and it gives me the value of 14,917. This is the value that maximizes my profit. I'm going to go ahead on the Data tab and select the Solver tool to show you how I got this number. In order to use the Solver, we have to first set our objective. This is the cell that we're trying to find the value for. In my case, this is the profit. This is the value that I'm trying to maximize. After setting my objective cell, I'm going to go to the max, and then I'm going to set my variable cells. My variable cell is the range from D7 to F9, which are all the 3 products that I'm working with. After setting the variable cells, I'm going to set up my constraint. In this constraints, I have set my range D9 to F9, which is greater than or equal to 0. From my second constraints, I have set the number of parts used must be less than or equal to the number of parts in inventory. After adding my constraint, I basically just click the solve button. It gives me a solution. As you can see, that this is indeed the value that maximizes the profit. For my second scenario, I am working with a personal scheduling for a fast food restaurant for employees, who are working 5 consecutive days with 2 days off. We're trying to find the schedule that meets demand for attendance level while minimizing the payroll cost. The goal for this model is to schedule employees so that we can have sufficient staff at the lowest cost. In this example, all employees are paid at the same rate. So by minimizing the number of employees working each day, we can minimize our cost. As you can see, I have different number of employees here. I also have the column for the days off. And over here, I have the total demand for each days of the week. This cell right here is the payroll. This is the value that I'm trying to minimize. I'm gonna go ahead on the data tab and click in the solver again in order to find the value that will minimize my payroll cost. I'm gonna go ahead and set my objective to the cell D20, which is my payroll cost. I'm gonna go ahead and then set it to the min, as I'm trying to find the minimum value. I'm going to then add in my constraint. And before that, I also have to add in my variable cells, which is the range D7 to D13, which is basically the number of employees that I have. I'm going to set in my first constraint by setting it D7 to D13, and I'm going to set this greater or equal to 0. My second constraint is that the number of all the employees must be an integer. And after adding all 3 of my constraints, I'm going to press the solve button. So as you can see, the solver gave me a solution for the constraints that I've added. I'm going to press OK. And over here, as you can see, the value that will minimize my payroll is 1,000. So as you can see, we can perform a lot more than this with the solver tool, but I mainly showed you guys how we can find the maximum value as well as the minimum value depending on what type of data we're dealing with. Solver tool can help us save a lot of time by adding in constraints that will return us the value that we're trying to find in.